Good morning, good afternoon, and good evening, everyone. Welcome back to our webinar conference, the fourth webinar conference on small and medium wind here from Nordic Folkecenter in Denmark. I hope that you have enjoyed what we have been having until now, and it has given some sense for you. And today it will be a bit shorter than the other days, but we are glad to now ask Mr. Mohammad Haghighi. I hope that I am pronouncing it the right way, otherwise you may excuse me. From AMarkWIND in Iran. And your presentation will be smart, affordable and reliable wind turbines for your home and business. Please, Mr. Haghighi, please go in.
Hi everyone, I am Mohammad. Let me stop the sharing my screen. We are from AMarkWIND. As you said, our product will be introduced today, and we're going to talk about our products more. And I am the project manager in this project, and this group has been established in 2016, and now based on our business model, we are going to continue our business in Denmark next year. The AMarkWIND is a new brand for wind turbines with an optimized design from electrical, mechanical, and economical point of view. In this project, different geometries of wind turbines have been studied, and the advantages and disadvantages to each of them have been used to design this product. Besides high performance PM generator and also electronic controller and monitoring systems have been designed for these products, and they would produce renewable electricity with more reliability, efficiency, and safety. Currently, our small-scale products suitable for householders and small businesses are ready to get necessary certificates and enter to the market all around the world. We had micro products also. We call them Prima 500 watt hybrid. They were, as you can see in the pictures, they are hybrid wind turbines, the Savinus vertical axis wind turbine type with twisted blades. We had installed several of them in Iran, as you can see in the picture. And we have several patents certification for our products. Here you can see 3 of them. I know that you all have some experience with horizontal axis wind turbines and also vertical axis wind turbines, and you know the differences as well, but I'm going to talk a little bit about them. Vertical axis wind turbines, as you know, are omnidirectional. They don't need any yaw system, and according to recent researches, they have lower weight to swept area ratio, and there are possibility to reduce their production costs also, and the possibility of a rotor larger than 10 megawatts is available for vertical axis wind turbines. The vertical axis wind turbines are stable, and it's because of the rotational of the rotor above the axis of tower, lower noise and raindrop due to low rotation. strong advantages, and according to recent research, again, the floater for a vertical axis wind turbine could be lighter, and therefore the cost would be lower for this kind of wind turbines. But also they have some disadvantage too. The aerodynamic efficiency in most of vertical axis wind turbines, especially I'm talking about the Darius kind of wind turbines. They lose the energy due to drag force on struts, and this is an issue in this kind of wind turbines. The lower rotational speed, it will result lower speed generators to be used in these turbines if we don't want to use gearbox. In two cases, we should use a gearbox with in other case we should use lower speed generators. Variety of geometries, and in this kind of wind turbine we see lots of geometries and this kind of wind turbine, and they haven't been industrialized yet, and it's I think a real problem with vertical axis wind turbines also. And they have vibration due to oscillation of torque produced by each blade, which is somehow a problem in this kind of wind turbines. Well, but about the horizontal axis wind turbines, as advantages, they have optimized and industrialized design because of some historical reasons, and they have higher aerodynamic efficiency in comparison to vertical axis wind turbines, and they have variable pitch, variable blade pitch, which give them the optimum angle of attack in different situations. But they have several disadvantages too. Essential need to have a yaw mechanism is one of the problems that to be considered as a disadvantages when we are comparing this kind of wind turbines. And also their weight increase when their swept area is increasing, and it's because of larger stress on blades. And they create noise due to high rotational speed, and also raindrops, erosion are one of the problem in designing the blades and their material, especially in the tip of blades. And also more bird death because of perpendicularity of their path to the direction of rotational blades. These were our thoughts about this kind of wind turbines. As you see in this slide, according to recent researches in DTU and also Delft University, we can see that the blue figure that it shows that the swept the ratio of the weight ratio of blade is lower in comparison to the horizontal axis design. About the AMarkWIND rotor configuration, as you can see in this picture, there are the main parts of the rotor. We have optimized blades for especially V-shaped rotor configurations. As you can see, the blade supports light structured struts with new aerodynamic cover, strut supports, and also the rotor hull. We have, as you can see, several innovative features in our product. As I can say that the rotor geometry is new. The struts design are completely new design, and we have pitch control mechanisms for our large scale wind turbines, especially designed for V-shaped vertical axis Darius wind turbines. The blade designs are especially for V-type vertical axis wind turbines. Blade supports and also electronic controls design that we use artificial intelligence to increase the performance and safety of our products. Well, about the rotor geometry, as you can see in this slide, the angle between blade and struts have been optimized to gain the maximum swept area. And also we have optimized the length of blade and struts to get the better mechanical performance and also lower product price. We use one strut design for each wings, and we use two blades for each wing that it would result lower transportation and also installation process and costs. The blade support and strut supports have been introduced to the rotor's geometry, and the rotor designed to connect to the rotor of a high performance axial flux permanent magnet synchronous generator directly, and the rotor of turbine and the generator is directly connected to each other, to the rotor of generator. Well, in the designing of the blades, we have chosen the high performance airfoils for the blades, and the chord length of the blades have been optimized. As you know, the solidity factor is one of the most important parameters in designing the aerodynamics of the rotor and also mechanical performance of the blades. Therefore, we have choose the right airfoils. And regarding the geometry of rotor, as you see, the V shape, we twisted the blades to optimize the angle of attack along the blades and increase the performance of the aerodynamic performance of rotor. And we choose easy to assemble connections to ease the assembling of their blades on the rotor. As you can see in this figure, we have demonstrated that the different performance of rotors. As you can see, the blue curve is related to edge rotor strut blade with strut blades, and the green one is related to a V rotor with twisted blades. Well, if we compare these two curves, the maximum power increased by almost 5%, and the rate and the maximum power would occur in a lower tip-speed ratio, and that will decrease the centrifugal force on the blades almost by 36%. About the strut design, we choose the thinnest strut design for decreasing the aerodynamic efficiency loss in the rotor, and we have designed a new airfoil for covering the structure of the strut, and we have a patent for that airfoil. Strut supports designed to increase the mechanical performance. Because of this support, we will be able to decrease the weight of strut, and it has important effect on the production cost of the struts. And also we have again easy to assemble the connections in the designing to connect the struts to the rotor's hub. As I said, we have blade supports introduced to the geometry of rotor. The blade supports has to be we have to consider the angle between the support and the blades in order to decrease the aerodynamic effect of these new features. We have optimized the angle, and the aerodynamic efficiency and mechanical performance, they both are in optimum situation. As you can see in these graphs, we can see the deformation of the blade in case of using blade supports in the left. The deformation on the tip of blade is 7 centimeters, but when we don't use the supports, the deformation would be almost 10 times larger, and this is a good achievement to decrease the weight of blade and also the cost of producing the blades. About the pitch control mechanism that is especially for designed for larger rotors, as you can see in this picture, we used a joint, a universal joint, and also a servo and gearbox to orient the blades in different situations. This is under developing, and we are working on that for our larger rotors to be used on those products. We have specially designed electronic control design for our products. The aerodynamic performance of rotor and electric performance of the generator has been considered to design a compatible controller. The integrated electronic unit with advanced artificial intelligence algorithms have been designed in this unit, and we have considered self-test algorithms to decrease the maintenance cost. And also we would have fast charging modules for electric vehicles option in our small products. The advantage of our products would be in this slide. They are burst friendly, and because of their rotational direction, we believe that the impact of blades burst would be decreased in this kind of wind turbines. They are affordable and economic because of the innovative design in the rotor, and also the compatible design between the all main part of the turbine, like blades, generator, and also the controller, which are the main parts of a turbine. Therefore, we believe this product is affordable and economic in comparison to other kind of wind turbine in the market. They are harmonic and silent. They are vertical, and therefore they have lower noise, and they have almost no noise in comparison to other horizontal axis wind turbines. Well, the development of this product lead to a high performance rotor. The power coefficient of our turbine is is comparable and comparable with horizontal axis wind turbines, and it's we can say that it's really it has a good trade-off between the performance and energy output in these products. They are durable and safe. We used active pitch controller to decrease the stress on the blades and also on tower, especially in larger products. And also we used electronic control unit with AI algorithms to decrease the to increase the safety of turbine in different situations. And also they are smart and intelligent. As I said, we have used artificial intelligence and also machine learning algorithms to optimize the performance of our product in different situations. Here you can see our test center. We are in this picture. We are testing our generator using power meter in our lab. With the performance of the generator, according to our tests, were about 92%. And it was a good performance for a generator. It was our prototype generator, and of course we believe in the final product, the performance of the generator would be increased. And we built several model scale prototypes, and in this picture you can see that we were testing our turbine using a moving truck method, and also we transported the turbine in to different locations with higher wind condition. And here we were installing our 1 kilowatt wind turbine in the University of Urmia. It has been working. It has been operating almost for 1 year, and you can see the final product, the AMarkWIND 1 kilowatt with anemometer, and we were testing the performance of Rotor during last year. And here is the spec of specifications of our 5 kilowatt product. The rated power is 5 kilowatt. The swept area of the rotor is 34. The cutting wind speed would be 3 meters per second, and also the rated wind speed designed to be 10 meters per second. The generator is, as I said, axial flux permanent magnet synchronous generator with 3-phase winding. The controller would be off-grid, and we will use MPPT and PMW for the controller. And the tower is lattice, 18 meters. Of course, the tower is optional based on the location and location of installation. The tower would be different. We will use the electrical and also mechanical braking system for the safety of rotor and turbine. Based on the components we have used, the designed lifetime would be more than 20 years. And the annual energy output at the 6 meters per second would be almost 12,500 kilowatts per kilowatts hour in a year. And according to IEC classifications, our turbine has been designed as class 2. Well, we have some roadblocks as in this conference we have talked about them, but the main problem in this market, I think, is the small wind turbines are not economic for householders considering their price based on the products in the market, the certified and proven products I'm talking about, not the other fake products. The most of turbines in the market are not looking fancy or and harmonic. Their design are, I think, is not beautiful. And also some brands make noise that is really a problem for them to be installed in the European countries. And some people, because of some other kind of turbines, fake turbines, do not trust on the performance and power output of the turbines. Last days, we have some speakers talking about that. And also the maintenance costs are high in lots of brands, which it has a negative effect on this market. Well, we are claiming that our products are competitive, has competitive price. As I specified, the AMarkWIND is designed to reduce the cost of wind energy, and we used our talent and knowledge to design a complete product with competitive price, since it is the master key in this business. Sustainable growth. Our company is going to use the skill and the management strategies to work on small scale wind turbines, and also develop our larger wind turbines and stay in the market.
We are running out of time, so
I'm finishing. Okay.
No, but there's still a little space. But if you take 1 or 2 minutes to finalize, it'll be very good.
Okay, that's okay. We have compatible components, as I said, and we have a risk-free sales method, and almost we have win-win agreement that I'm going to present. We will make our customers to feel winning by buying our products. The AMarkWIND 5 kilowatt is an ideal choice for householders to generate clean electricity for their home and also their electrical cars. The customer would pay the turbine's price in 6 or 7 years, and while their annual payments would approximately be equal to their previous energy bills. And the customers would enjoy this. After that, they would enjoy the almost free energy. And also, this business would create some jobs in the market. We're starting our business in Denmark next year, and as you can see in this figure, there is good wind availability almost all around almost all regions in Denmark, and it shows a good availability and good resource for generating wind energy. Well, this is my contact information. You can contact me, and we could have a talk about our products and also the cooperation availabilities. Thank you for your attention.
Thank you very much. It has been interesting. We still have a short time. Are there any questions? Yes, I see there's a question. Vinit, there's a question from Vinit Haghighi or Haghighi. Excuse me if I'm not pronouncing your name the right way, but I hope you can live with it. Vinit, you had a question.
Yeah, so Mohammad, I had a question regarding your B configuration, which you show some load calculations. Could you give us some approximate what operating conditions do you consider to do those load calculations?
We have several. We are developing several products, and for considering for 5 kilowatts, we considered 10 meter per second for the maximum power output of the rotor, and also we have considered 42 meter per second for parking situation of the turbine when it's hurricane, and I think well, the rated power for our turbine is 10 meter per second. Therefore, we have considered this wind energy for wind speed for the calculations.
Yeah, because I can imagine the V configuration is subject to adverse loads as compared to the straight blade configuration. So would that affect the structural integrity in some ways?
Well, consider a swept area with a fixed amount. Well, the blades would the swept area of the rotor would be equal in these configurations. Therefore, the force and loads on the blades and also structure would be equal in both of them.
Okay.
Yes.
Thank you very much. We will make a follow-up later on today. So if there will be further questions, I think we'll take them up, because to keep time, it's a little bit over, but I hope that you, Vinit, will excuse that.